finding nth roots of a complex number. And so there's this kind of really ugly formula that says if you have a positive integer n and a complex number in trig form, such as this, that it will have exactly n distinct nth roots that are given by this lovely formula.
Is the I sign on the top or is it?
It's like I sign of all of this. So like this is like the cosine of all of this, I sign of all of this. So it's the sine of theta plus 2 pi k all divided by n, where k equals 0, 1, 2 to n minus 1. So like if I said find the cube roots, then n would be 3, and there would be 3 answers. It has n distinct nth roots. So if I said find the cube root, n is 3, and you would have 3 answers. If I said find the fifth roots, then n would be 5, and you would have 5 answers. If I said find the square roots, then n would be 2, and you would have 2 roots. So this is a lovely formula.
Did you get it on test?
I don't think so. It's not that bad to do. I'm going to show you how to use it.
I saw it.
I know, but once you do the formula once, it's just repeating it over and over again. But you're right, they are long. That's why we have to get started. Okay. Ready? Remember how I showed you the CIS thing yesterday and I told you it was crazy? I found it in your book yesterday.
See, that's where you thought that was where it came
No, I found it in the other book. But in your book it says, over in the side notes, what is CIS? Trigonometric or polar form appears frequently enough in scientific texts to have an abbreviated form. The expression cosine theta plus I sine theta is often shortened to CIS theta, pronounced kiss theta. Thus, D equals R kiss theta. Just saying that, maybe it shows up more than I think. Everybody done writing this yet? The big thing I want to point out is when you're doing this, you have to remember to start with k equals 0. So when you start with k equals 0, notice that that's just going to go to 0. So your first one's going to just be theta over n, and then you'll do k equals 1 all the way up to n minus 1. We'll start nice. We'll start with square roots, and then we'll do crazier ones. You sure? Oh, a pencil break. Nice thing is when it's in trig form, all right? Find the indicated roots of the complex number, give standard and trig form. Square roots means there's 2 answers, but you always start with k equals 0. So we're going to do this twice, right? Square roots means n equals 2. And so we're going to do for k equals 0, and then we're going to do it again for k equals 1. Notice that in the formula I said theta plus 2 pi k, right? What if this is in degrees? Do I need to change it to radians, or can I adjust my formula instead of saying plus 2 pi k, could I say plus 360k? So like you can adjust that as needed if you're in degrees or radians. So just be aware of that. So if I was going to do this, I'm going to say the square root of 16, square root, times, and I'm going to show lots of work this time, cosine of theta plus k is 0. So it's 360 times 0 all over n, because it's root, n is 2. If you just know this is 0 and you just automatically take 60 divided by 2 and say 30, that's okay too. But I just want to show you that that's what the formula is saying. And I'm kind of, I'm going to be doing a lot of stuff. So I just say plus I, da da da, because I know it's going to be the same thing over there. So I simplify this and then I write it out nicer. Do you want me to write it out better on this? I write it out underneath it here. Like I actually.
Straight up, if it was like 4th root, maybe 4th root 16 over 2.
Right, it would be the 4th root of 16, and this will be a 4 on the bottom. And so this would just be 30 degrees plus I sine of 30 degrees. So that's what I mean by, like, I just kind of write it out to begin with. There's no need to write that fraction twice, and then I simplified it and write it underneath. If it said leave it in trig form, that's the answer. This says give standard and trig form, so next to this I'm just going to kind of work it out. And again, you can use your calculator to help you on this, but I hope 30 degrees is a pretty easy one to do, that the cosine of 30 degrees is square root of 3 over 2, and the sine of 30 degrees is 1/2. So that would just be, not 30 degrees, right? It's down here. Isn't it square root of 3 over 2 1/2? Because up here is 1/2 square root of 3 over 2. Okay. So this is 2 square root of 3 plus 2i. That would be the standard form. That would be the trig form. That's only one root, though. I want the square roots. So whatever n is, that's how many answers you're going to have. So now you just repeat the process. The only thing that changes is now k is going to change to 1. Right, they just take some time.
So you just go, okay, and then it's just there, you're just showing us that the square root is like these two.
Yeah, and if it said cube root, n would be 3. Fifth root, n would be 5. So on this one, it would be plus 360 times 1 divided by 2. And just watch your arithmetic here. Some people like to just take this number and add 360 to it. You have to add 360 and then divide by 2, right? So that would be 60 plus 360 is 420. Divided by 2 is 210. Is that true? So that would be 210 degrees plus I sine of 210 degrees. And in standard form, 210 degrees is just down here, right, in the quadrant 3. So it's the same as this, only now we're negative, right? So now it's just going to be 4 times negative square root of 3 over 2 minus 1/2 I. So that's just going to be negative 2 root 3 minus 2i. And you might say, is it always going to be like that? Can I just make one a positive and one a negative and it always works? There's going to be a negative in there. If it's a square root, something's going to change. Depending on what the first angle is, it might just be one of them changes. So I say don't look for that super shortcut because there's always exceptions to the rule. But it does kind of make sense if you think about when we take square roots that we do plus or minus, that they're opposites here. That's it. Square roots, we found 2 solutions. We did that.
What's the highest you're going to go?
5? I don't know.
I know a lot of roots.
No, but it's a pattern. Let's do a pattern. Let's do this one so you can see there's a pattern. I think there's a 5 on your homework. What's different about this one from the last one besides it says cube root to the square root?
Standard form.
It's in standard form, so we need to put it in trig form first. The good news is, can you just tell me where is negative 1/2 radical 3 over 2 on your unit circle?
No, here.
2 pi thirds. Isn't it 2 pi thirds?
Yeah.
I was right the first time.
So the the unit circle like makes it easier. I about like pulled that whole printer off by stepping on the cord.
Yeah, you gotta use that much.
You might say, well, I want to distribute the 8 and then do it that way. You'll still end up with 2 pi thirds, but they've kind of set it up perfectly. They have kind of the r out front already, and then they have that there. So negative 1/2 square root of 3 over 2 is 2 pi thirds. So you can do this as 8 times cosine of 2 pi thirds plus I sine of 2 pi thirds. So that's not a terrible one to put in trig form. You do have to think about it. What is n in this problem? 3. No, n is 3. The cube roots. Right? N is 3. So I'm going to do this 3 times, starting with k equals 0, and then k equals 1, and then k equals 2. Ready? So I'm going to do the cube root of 8 times the cosine of 2 pi thirds plus k0. So I don't know. I always just say plus 0 over n is now 3. Right? And again, I don't ever rewrite it again, because why do I need to rewrite the arithmetic that I'm just going to rewrite underneath it? Works out really nice that the cube root of 8 is 2. What do you get when you take 2 pi thirds divided by 3?
Cross out the
Don't you do 2 pi thirds?
cross the 3's out. Just cross out the 3's.
No!
You do 2
Yes.
pi.
Cross the 3's out.
If you had something like this, you could cross the 3's out because they're both in the denominator. But this is the same as saying 2 pi thirds divided by 3 is the same as multiplying by 1/3, which means it's 2 pi
Dang,
ninths.
I have to have it done.
Cross out the 3 and then
If this said put it in standard form, is 2 pi ninths in our unit circle? Which means if they said put it in standard form, you would have to give me a decimal answer. Right? Like it's not going to be a nice answer if it's not in our unit circle. Let's just leave this one in trig form. But you could work it out with a calculator. You would just take 2 times cosine of 2 pi ninths, 2 times sine of 2 pi ninths.
it's not only going to k equals 2, right?
Yeah, we always have to go to k equals 1 less than this. So now I have to do it 2 more times. So I'm going to say the cube root of 8 times the cosine of 2 pi thirds plus 2 pi divided by 3. So that's times 1. And you can use your calculators to help you. I like to show you that you can add fractions, maybe, without a calculator. 2 pi would be 6 pi thirds. Yes, I did.
What is the top right? What is this?
What does this say?
Yes.
2 pi thirds
No, the top right, that one.
plus 2 pi
2 pi.
times 1.
Yeah, thanks.
Yeah, why are we doing 2 pi now?
Instead of what?
0. I know it says 1.
I just didn't put the 2 pi here because anything times 0 is 0. But isn't it 2 pi k?
And the k would be 1.
K is 0 on this one, k is 1 on this one.
And then on the next one will be 2, so it'll be different.
Right, so it would be 4 pi. Right. It's 2 pi k. When k is 0, I just always put 0 there because I know 0 times with k is 0. 2 pi plus 2 pi thirds, I believe, is 8 pi thirds.
Yeah.
Divided by 3 is 8 pi ninths. If you cannot add that very well, just do it without the pi's. Take 2 thirds plus 2 and then divide by 3. And it should give you 8 ninths. Again, not from our unit circle. One more time. Yep.
You say it's okay to leave like on the homework, you want us to work it out?
What do directions say? Like if the directions say give standard form, then you type it in your calculator. If it says give trig form, then you type it in your calculator. Right? Like you just get a decimal answer, which is a good approximation. I think on the next one we're gonna do trig and standard form, so you can see that it's okay to use this. Third one, and it's still 3, and now I'm going to do cosine of 2 pi thirds plus 2 pi times 2, because now k is 2, divided by 3. So it'll be 4 pi. So 4 pi plus 2 pi thirds would be 14 pi ninths when I divide by 3. Here's what I want to show you about this. Usually you can look for a pattern, because if you just keep adding multiples of 2 pi and dividing by the same number every time, I could give you one that said find the fifth roots, and you can find a pattern pretty easily. Like on this one, what do you notice the difference between this one?
6.
You just add 6 to the top number, and I could get this one, right? So what I usually do is I do the first two, especially if it's more than 3, like if it was the fifth roots, I do the first two, and then I say, oh, what am I doing each time? And maybe I check to make sure it worked for the third one. And then you can just keep going from there.
Can you finish the answers?
Yeah.
Hey, well, what if you have to put in standard formula?
Then you would still have to type it in your calculator.
So really, you can just copy down that part.
It's just long. It's not terrible. We've done way worse thinking types of questions than this. It's just typing it in your calculator. I have class tonight.
Bring the class.
I can't. That's why I have a good grade, because I go to class. That's the key to life. I can't. Today's the review for the final. As much as I pretend that I don't care and that I can get this grade, like knowing that I can do bad in the final and still do okay in the class, like, is nice. But I'm a nerd. Like, I want to do well in the final. I don't want to walk in and get a 30 on the final. Like, I don't want to do that. No, I want to do well in the final. Like, he would be sad if I didn't do good on the final.
You can almost not show up.
I gotta set the curve, right? I'm an overachiever in life. That's why I'm in the wrong profession. Just kidding.
So, cube roots of 1,000. 10.
Cube roots of 1,000. Lots of people like to say the cube root of 1,000 is 10. That's
You're gonna say it's not right, aren't you?
fundamental theorem of algebra says that for a polynomial, if I said x cubed equals 1,000, how many solutions does there have to be to that polynomial? There has to be n solutions. The other two are going to be imaginary numbers, which is why we have this complex numbers here. So you're going to have 3 answers. N equals 10, or x equals 10, or whatever. That's going to be one of your answers you get. There's also 2 imaginary. You could solve this if you remember how to factor cubes. Remember factoring perfect cubes? Probably not. And then you could do the quadratic formula. That would work as well. But we're going to practice doing this. Okay.
You just factor out an x, right? X times x squared.
No. Don't write this down, but this works into x minus 10 times x squared plus 10x plus 100.
Yep, I don't remember that wrong.
First semester.
Oh, we're not.
There's 3 answers here. So n equals 3, and I'm just going to say the cube root of 1,000 times the cosine. Oh, wait. How do I write this in the right form?
Would it just be 1?
Look, I kind of jumped the gun here, kids. Would this be the same as like 1,000 plus 0i? Which means what would r be?
I can't remember how to do r. How do you do r again? What is square root of 2 times 1,000?
It would just be 1,000, right? It would be the square root of 1,000 squared plus 0 squared, which is just 1,000. Because if I graph this, this would just be at 1,000 on the real axis, right? Which means what angle am I at?
Pi, 2 pi.
0 or 2 pi if you prefer.
Pi.
Right? So theta equals 0,
4 pi.
r equals 1,000. So it's 1,000 times cosine of 0 plus I sine of 0. If you like degrees better than adding the 2 pi, like if you like adding 360, you can make that 0 degrees. I like 2 pi better. I do better with radians, so I'm keeping mine as 0 with no degree sign. We know the cube root of 1,000 is 10, so we better get 10 here. Then we should get some imaginary numbers after that. So now I can say the cube root of 1,000 times the cosine of 0 plus 2 pi times 0 over 3. That's kind of a lot of silliness, right?
That's 0.
Right. That's just 0 plus I sine of 0. Because 0 plus 2 pi times 0 is still 0. This is where the nice answer comes in. The sine of 0 is 0. The cosine of 0 is 1. So,
Oh, you went up right.
So 10's an extra twice.
well, you know, we said 10 earlier, but I was just showing you how you can get it doing this.
I thought we were doing another one. That's why I was like, you really got to specify all that.
I have to do them in order. I can't just skip to Kegel form. I'm just showing you how it works. So now I'm going to say 0 plus 2 pi times 1 divided by 3. Which is not bad math. What is 2 pi divided by 3? Is just 2 pi thirds. And I'm going to work this out. The cosine of 2 pi thirds is negative 1/2. And the sine of 2 pi thirds is radical 3 over 2. So that would be negative 5 plus 5I radical 3. That's the solution. Third one. Cosine of 0 plus 2 pi times 2 divided by 3. And again, use what I was saying about the pattern. I went from 0 to 2 pi thirds, so it should make sense that we're going to go 2 pi thirds more. And do I get that? Do I get 4 pi thirds for the next one? Like, there's always a pattern with these because it's adding 2 pi and then dividing by the same number. So that would be cosine of 4 pi thirds and the only difference between 2 pi thirds and 4 pi thirds is both x and y are negative now. You agree with that?
Yes.
So if you know that, you don't have to show all the work every time. But that would now be negative 1/2 minus I radical 3 over 2, which means it's going to be negative 5 minus 5I radical 3. And again, that comes from the fact that if we solved that equation, x cubed equals 1,000, what you would have left would be a quadratic, and you would do the quadratic formula, and you would get the plus or minus there. That's exciting, right? This is it for chapter 6. It's a good place to end chapter 6, right? Tomorrow we're going to review, and we've done a lot of stuff, so I'm going to try to really hone in on these are the things that you have to know for your test, because obviously I can't write a test that has every single thing that we've done in this chapter because it would take us 3 days to take that test, and I really want us to only take this test on Friday. So
You're gonna get the fun stuff on it?
the good stuff.
The easy stuff.
Like this kind of thing. This is good. Chapter 6. 6.6, that lesson, that's good.
That is a good lesson. I'm pretty sure there's no, besides graphing polar coordinates, right, where you just have to make the dot, I'm not going to put any other polar graphs that you have to make. You need to identify a couple, know if I wrote this as a rose curve, or if I gave you a rose curve, the equation, or, but that's it. So that'll be
a review question about that.
I'll have review stuff for you. But this is your last homework besides review, and so let's I'm gonna take 49 off of here for you. Well, 46 and 49 were both fivers, so
I'm trying to give us 10. Thanks for taking off there.
55. 55 to begin with.
How many is that?
So, there you go.
How?
I want you to look for the patterns in those, though. Like on the fifth roots, once you do 2 or 3, you should just be able to get those other angles right away.
It's a sixer.
It is a sixer.
It's not.
It's a pattern. Like once you do 2, like you can just do the rest. And you actually have like 10 minutes to work. So